Now that we've solved equations with radicals, we're going to move on to solving equations with rational exponents. A rational number is a fraction. So I always try to kind of help you remember by saying ration rhymes with fraction. So when we solve equations with rational exponents, we're going to have a fraction in the exponent or in the power. So let's take a look at our steps. Step number 1, similar to the radical, you want to isolate the term with the rational exponent. Meaning you want to get that term that has that fraction power on one side of that equal sign all by itself. Okay, after you do that, you're going to raise, that's important because we're going to raise it to a power, both sides to the reciprocal. Reciprocal means just to flip that fraction of the exponent. And there's one thing to note, so this is kind of a big note, because you'll see one of these on your test. If the original numerator is even, add in plus or minus. And I'll show you what I'm talking about on that in just a little bit. And then step 3 is to solve. Okay, so write those steps down and we're going to go through and solve. Okay, example 2. Solve the following rational exponent equations. And sometimes it's kind of hard to see what the powers are, so be sure you watch real careful. So I'm going to write this one down again. It's x to the 5/4 equals 32. I know it's a rational exponent equation because I have a power that's a fraction. So step number 1, isolate whoever has the fraction power, which in this case is x. He's already all alone. Step number 2 is to raise both sides to the reciprocal of the exponent. Now, looking at my original numerator here, the original numerator being the number on the top of the fraction, is 5, which is odd. So I don't have to worry about that note that I wrote down about my original numerator being even. If you look at part B, where my numerator is 2, then I'm going to have to be concerned about that note. Okay, so I have x to the 5/4. We're going to use our calculator on these. But what I'm going to do is I'm going to raise both sides to the reciprocal. So the reciprocal of 5/4 is 4/5 of that fraction. Being really careful that you're not multiplying by 4/5 but raising. And we do that because 5/4, if I have a power to a power, I multiply across those parentheses. 5/4 times 4/5 is technically 1. And so that just leaves me x to the first power, which is the goal. And then in your calculator, you can just plug this in. Now, technically, if you really want to know what's going on here, 4/5, the 5 is the root of this. So basically it's saying take the 5th root, find the number that multiplied by itself 5 times gives you 32, and then raise that to the 4th power. But you will be safer if you just plug it in your calculator. So we have 32. To get the power, you're going to use the caret top. So if your calculator is not like mine, use the caret top. And if you use the caret top, be sure you put that fraction in parentheses. So 32 to the 4/5 power gives you 16. And that's your answer. So way fewer steps than solving those radicals, some of them. Okay, part B, same thing. Actually, let's do part C, then we'll come back to part B. Let's look at part C first. On part C, we have a rational exponent right here. And step number 1 says I need to get that on one side of the equation by itself. So in this one, I actually have a minus 16 over there with it. I need to get rid of that. To get rid of it, I'm going to do the opposite operation of addition. So I have x to the 2/3 equals 16. At this point right here, this one looks a lot like part A, except watching that original numerator right here, because that numerator is even, when I raise to the reciprocal, I'm going to add a plus or minus on the other side of the equation. So here's what we're going to do. I have x to the 2/3. The reciprocal is 3/2. If I do it on the left, I raise it on the right. So 3/2 in the power, right? So you're using the caret top, it's not multiplication. And I'm going to add a plus and a minus out front. So the 2/3 times 3/2 leaves me x to the 1st equals plus or minus. Let's plug in 16 to the 3/2. And you get 64. So if your original numerator is even, you're going to end up with 2 different answers, and you could go through and check those answers and they will work. So 64. Okay, let's go back up to part B. So write that down. Let's go up to part B. On part B, we have x minus 3 to the 2/5 equals 4. So I already have my term with that rational exponent by itself. My original numerator is even. Okay, so it's what you start with. I'm going to raise both sides of this. So I'm going to use brackets, because I don't like parentheses within parentheses. So I have 2/5. Reciprocal of that's 5/2. Whatever you do on the left, you do on the right. And because my original numerator is even, I'm putting a plus or minus out there. If your original numerator is odd, do not put that plus or minus. Okay, so on the left, these 2 reciprocals go away and just leave me x minus 3 equals plus or minus, and you should be able to calculate each of these with these crazy powers to get a cleaner number. Okay, so 4, not including the plus or minus in your calculator, 4 to the 5/2 gives you 32. Okay, so x minus 3 equals plus or minus 32. I need to get x alone. This one's not alone yet, so I'm going to add 3 to both sides. Keeping in mind, I have plus or minus 32. It's not just a regular 32. So same as always, anytime you have a plus or minus, anything you add or subtract over is going in front of it. Because I could put 3 and 32 together, I can actually clean this up. So it will be 3 plus 32, which is 35. That's one answer. And it'll be 3 minus 32, which is negative 29. So there's my other answer. Before I work the checkpoint, I want you to take a look at it and see, tell your neighbor, do you have any idea how to start it? What's the problem that we haven't had before, and how would you start it? Okay, so on this one, hopefully you noticed I have 2 different things that both have a rational exponent. Everything so far, we've only had one with a rational exponent. So since I have 2, I need to get one of these terms on each side of the equal sign. So I'm going to add 6x minus 1 to the 1/3 to both sides. Okay, so then on the left, I have this 2x plus 5 to the 1/3, and on the right, I have 6x minus 1 to the 1/3. Looking at those fraction exponents, both of my numerators are odd, so I don't have to worry about the plus or minus. To undo a 1/3, its reciprocal is 3/1. And notice here, whoop, those are going to go away on both sides and leave you 2x plus 5 equals 6x minus 1. Is that quadratic? There's no power of 2, excuse me, on x. So no power of 2 on x, so it's linear. I need to get my x's on the left, numbers on the right. So let's subtract our 5. I have 2x equals 6x minus 6, and then subtract our 6x, keeping in mind it doesn't matter if you move the number or the x first. If you like moving the x first, that's great. Have at it. Okay, so I have negative 4x equals negative 6. To solve for x, divide by negative 4. If I reduce, negative over negative is positive. 6/4 is 3/2. And remember, you could type that in your calculator. It's going to give you a decimal, but hit math, enter, enter. It'll get you back to a fraction.